Good morning, everyone. Thank you for joining us. Just to make sure everyone can hear, could you give me a little thumbs up or some type of reaction? Just want to make sure everyone can hear us this morning. Okay, I see a few thumbs up. Perfect. Well, my name is Shanna Weber, and I am an environmental education assistant with the Environmental Assistance Branch in the Kentucky Department for Environmental Protection. We are so excited that you were able to join us this morning. And before I hand the presentation over to Clayton and we dive into today's topic of ambient air monitoring in Kentucky, I'm just going to do a little bit of housekeeping and let you know a little bit more about what ECAP is and what we do. So first things first, if you've never used GoToWebinar before, if you're here with us, and I think you should be able to hear me, you should be pretty much all set. Everyone besides our presenters are going to be in listen-only mode, so you will not have access to the microphone or the camera. But if you do have any questions at all throughout the webinar, we ask that you use the questions feature, and we will try to get to your questions throughout the webinar. I also want to point out the captions feature at the bottom right-hand side of your screen. This is just another great tool that provides closed captioning throughout the webinar. With that being said, I do also want to let you know that this webinar is being recorded, and I will be working to send it out within the next couple of days, along with the presentations that we're going to be using today. So, what is ECAP? I'm going to refer to us as ECAP. We are the Environmental Compliance Assistance Program in Kentucky. And if you take anything away today from my short little talk about ECAP, it is that we are genuinely here to help you out. The program itself has two main objectives. The first is going to be helping businesses understand and comply with Kentucky's environmental requirements. And then the second is to provide free and confidential assistance to Kentucky's businesses. And we're going to talk a little bit more about what that looks like. So ECAP acts as Kentucky's Small Business Environmental Assistance Program, or SBEAP. SBEAPs are a requirement of the Clean Air Act, and we are actually primarily funded by air emission fees. So for that reason, we do specialize in assisting small businesses, and the small business is going to be those with fewer than 100 employees. They must be independently owned and operated, and they cannot be Title V sources. We specialize in providing air quality assistance to small businesses. So our biggest duty, I would say, is providing that technical assistance, specifically specializing in small business and air quality. We can offer detailed air quality assistance to businesses, including doing site visits, doing potential emissions calculations. We can also do things like develop the entire application, like an air permit application. We can help fill out forms. We can also develop record keeping and reporting spreadsheets for different air permit requirements as well. So Kentucky has actually opted to make our SB program multimedia, where some states might just focus on air quality. So we'll actually focus on air, water, and waste. We do staff a phone and an email hotline to take in requests from companies and the general public. So we can provide general assistance in several water and waste topics. Generally, we will get questions on things such as KPDES permits or hazardous waste. But for some areas, if we don't necessarily know the answer to your question, we can act as a referral service, and we can send you to somebody who might know a little bit more about your question or the specific topic. We can also help facilities identify if regulations may be relevant, and we can recommend that they review certain regulations to help them identify applicability for their operations. And then we also can assist with new economic development projects, helping individuals identify potentially applicable permits, because we all know that that's sometimes hard to do. We can help companies new to Kentucky get into meetings with the different divisions within our department all at once, rather than just going through them each individually as well. Finally, we also do a lot with education, specifically environmental education, to permitting and just regulations. We develop educational documents for the public, and this can be everything from quick one-page fact sheets to 80-page compliance documents that might cover every single potential regulation a facility in a specific sector might need to be concerned with. We also hold webinars and workshops like the one that you are attending today. We hold an annual 101 series of workshops covering basic air, water, and waste permits and regulations. I will have a list of all of our upcoming events at the end of the webinar, so stay tuned for that. We would love to see you at some of our upcoming events. And finally, we can also do meetings with individual companies for training or one-on-one assistance. So I've talked a lot about what ECAP does. Here are a few things that ECAP doesn't do. ECAP does not issue notice of violations or NOVs, even if issues are seen during a site visit. We do not make any sort of regulatory determination or give any requirements. We do make recommendations to facilities, so we have no regulatory authority. When I say we're here to help, I genuinely mean we are here to help. We also do not interfere with any inspector activity or anything covered in an inspection report. I'm going to go over our enforcement discretion in the next slide, and that does not supersede anything that an inspector might say or do. And then finally, ECAP cannot act solely as a corrective action or a remedial measure following an inspection report or a notice of violation. We can assist a facility meet certain requirements, but we cannot be a remedial measure in itself. So here is that enforcement discretion that I was talking about. I have mentioned a few times now that our services are confidential and we do not report on potential violations. That is outside of a few exceptions. The Department for Environmental Protection did create an enforcement discretion policy for ECAP. The important part of this is that facilities that work with ECAP are given a reasonable opportunity to correct violations before they are ever brought to the regulatory agencies. And finally, I just like to touch on a few of our accomplishments that we like to share. Our program itself has an average of 1,100 assistance requests per year, with 115 of those being detailed assistances. So that might be those specific air permit applications or recording and record keeping documents. 54% of our survey respondents are small businesses. We have received a 96% positive rating from respondents, with 94% saying that they would use ECAP again and recommend our services to others. And 87% of clients have made changes based on recommendations that we have provided. So that's going to wrap up my short little spill about ECAP, and now we can kind of move on to what everybody joined us today for, looking at ambient air monitoring in Kentucky. So with that being said, I'm going to go ahead and turn the screen over to Clayton Sanders. He's an environmental scientist within our Kentucky Division for Air Quality, and he is going to go into a little bit more detail on ambient air monitoring. So let me go ahead and pull up those slides for you. And you should be good to go.
Alrighty, good morning everybody. My name is Clayton Sanders. I am the supervisor for the quality assurance section of the technical services branch within the Division for Air Quality. I've been working for the Division for Air Quality for 7 years now. The first 5 years I spent as an auditor in the quality assurance section, and then I moved to the supervisor for the technical support section, and then about a year and a half ago came back to supervise the quality assurance section. Today we are going to discuss and talk about the state's Division for Air Quality, a little bit about the 4 branches within the division, and then really dive into the technical services branch. where we will give an overview of our ambient air monitoring program, the pollutants we measure and the equipment we use to do so, how we quality assure our data, and then how that data is used. Next slide. So the Division for Air Quality's mission is to protect human health and the environment by achieving and maintaining acceptable air quality through operation of a comprehensive air monitoring network, creating effective partnerships with air pollution sources and the public, timely dissemination of accurate and useful information, the judicious use of program resources, and maintenance of a reasonable and effective compliance assurance program. Next slide, please. So the state's Division for Air Quality has been operating for over 50 years. Our agency has been conducting ambient air monitoring since 1967. Currently, our division is led by our director, Michael Kennedy, and the division is split into 4 main branches. The Field Operations branch is primarily responsible for compliance evaluations of facilities. They also operate the equipment at our ambient air monitoring sites, and then they respond to air quality complaints made by the public. The Permit Review branch reviews applications from sources that require permits to discharge pollutants into the ambient air, and they also issue those permits that include all significant emission points and the conditions that have to be met for them. The Program Planning branch prepares state implementation plans. They use those to achieve and maintain national and state air quality standards. And then they also draft and process air pollution control regulations. And then lastly is the Technical Services branch, which is what we're going to dive into with a little bit more detail. Next slide, please. So the Technical Services branch is split into 3 sections along with some additional branch staff. First is the source sampling section, which is not part of the ambient air monitoring program, but their job is to review and approve protocols for air pollution source facilities to determine compliance with their permits. The other 2 sections, the quality assurance section and the technical support section, along with that couple other members of our branch, are directly involved in the ambient air monitoring program. The quality assurance section writes QA documents like a standard operating procedure. They conduct performance audits of all monitoring equipment in the state. They verify all of the data generated by our analyzers and samplers. They ensure every piece of equipment used directly and indirectly for air monitoring is certified and operating within its requirements. And then the technical support section procures all of our monitoring equipment from specialized vendors. They maintain and install all of the equipment in our network, and they operate and maintain our data collection system. They are also responsible for processing all of the data that is generated by third-party laboratories for us. Some of our other branch staff that don't fall into those 2 sections are responsible for things like writing our annual network plan and quality assurance project plans. They upload data to EPA-operated databases, and they also evaluate our sites annually to meet siting criteria set by the EPA. Next slide, please. So the complete ambient air monitoring network within Kentucky comprises of sites and instruments that are operated by the Kentucky Division for Air Quality, the Louisville Metro Air Pollution Control District, and the National Park Service. Currently, there are 33 different monitoring sites across the state with a total of more than 90 individual instruments. Each monitoring station is unique, containing a variety of equipment that is dependent on the monitoring objectives for that site and what pollutants are being monitored. Kentucky Division for Air Quality's monitoring stations are operated by the Field Operations branch and maintained by the Technical Services branch. Next slide. So this map depicts all of the monitoring stations located across the Commonwealth, stretching from Paducah all the way to Pikeville. Each marked location also displays the specific pollutants that are measured or the specific equipment that are at each location. All of the counties that have air monitoring sites within them are shaded. The blue counties contain sites operated by the Kentucky Division for Air Quality. The red county is where all the sites for the Louisville Metro Air Pollution Control District are located, and the green county is the site operated by the National Park Service. Next slide, please. So air monitoring stations and sites come in all different shapes and sizes depending on the location of the site and the specific equipment that we plan to operate there. On the left is our Middlesboro site where we measure ozone and PM 2.5. The top middle photo is of our Paducah Transit site where we measure ozone, SO2, NOx, and PM 2.5. The bottom middle photo is our NKU site up in Florence where we measure ozone, SO2, NOx, PM 2.5, and air toxics. The right middle photo is one of our 3 Calvert City sites where we sample for air toxics. And then on the far right is our Lexington site where we measure for ozone, SO2, PM 2.5, and PM 10. Next slide, please. So the majority of the ambient air monitoring network is designed to measure the 6 criteria pollutants that have been set forth by the EPA. These pollutants include carbon monoxide, lead, nitrogen dioxide, ozone, particulate matter, and sulfur dioxide. The rest of the monitoring network consists of special purpose monitors that often include meteorological equipment and air toxic samplers and analyzers. Next slide, please. So our instruments can be broken up into 2 categories, continuous and intermittent samplers. The first of which, continuous analyzers, are the most common types of equipment located within our network. These analyzers measure ozone, nitrogen dioxide, sulfur dioxide, and PM 2.5. These analyzers run constantly, measuring pollutants in real time, 24 hours a day. They relay measurement readings to our data telemetry system here in Frankfort, Kentucky, where we can view readouts and visualize pollutant levels across the state. These analyzers work by constantly pulling in ambient air and running it through different kinds of light attenuation, depending on the specific pollutant being measured. The intensity of the light attenuation is correlated to a known level of air pollution, and an ambient concentration is then calculated by the instrument. Next slide, please. So the first continuous instrument we operate in our network is for ozone. Ozone is a colorless gas that forms in the atmosphere naturally and is not a direct byproduct from a facility or a source. It is produced when a photochemical reaction occurs between volatile organic compounds, or VOCs, and nitrogen oxides in the presence of sunlight. Our agency measures for ozone at 21 different locations across the state. We use the Teledyne API T400 ozone analyzer, which is a continuous gas analyzer. The analyzer uses ultraviolet photometry to measure concentrations, and our network monitors for ozone from March 1st to October 31st as required by the EPA. This is because ozone concentrations are typically very low in the winter months and are not necessarily a concern. Next slide, please. So the next continuous gas analyzer we operate is for sulfur dioxide, or SO2, which is a colorless gas that has a pungent odor at high concentrations. SO2 is typically produced while burning sulfur-containing fuels. The most common source of SO2 emissions today are coal-fired power plants. Our agency measures for SO2 at 8 different locations across the state. We operate the Teledyne API T100 SO2 analyzer. These analyzers use ultraviolet fluorescence, where the molecules of the gas are irradiated by UV light, causing them to fluoresce. That light emission is then measured and correlated to known concentrations to provide a measurement. Next slide, please. The last continuous gas analyzer we operate within our network is for nitrogen dioxide, or NO2, which is a reddish-brown gas that comes from the combustion of fossil fuels at high temperatures. Our agency measures for NO2 at 5 locations across the state, and we operate the Teledyne API T200 NOx analyzers. These analyzers use a photometric detection of chemiluminescence by mixing ozone with NO and NOx gases at known levels. Next slide, please. The last type of continuous analyzer we operate in our network is for PM 2.5. So the other three were for gases. This is now for particulate matter. PM is short for particulate matter, which is a broad term used to classify pollutants that consist of very fine particles. PM comes from many different sources and can be made from many different materials, liquid droplets, and aerosols. PM 2.5 is a specific classification of particulate matter where each particle is 2.5 microns or smaller. We operate 14 continuous PM 2.5 analyzers at a total of 13 different sites around the state. We use the Teledyne API T640 PM 2.5 analyzer for that. The T640 uses particle scattering spectroscopy in order to determine the amount of PM 2.5 in the sample stream. Next slide, please. So in addition to our continuous analyzers, we also operate a number of intermittent samplers. In general, these samplers work by collecting pollutants on a filter or other media. The samples are set up and collected by our site operators in the field operations branch. Once collected, they are sent off to be analyzed by different laboratories around the country, depending on the specific pollutant that we're sampling for. Most intermittent samplers collect a sample for 24 hours on a set frequency, and the sampling days that they run are determined by the EPA on a national level, so that each sampler across the country all sample on the same days for data comparisons. Pollutants commonly measured with intermittent samplers include PM 2.5, PM 10, lead, and air toxics. Next slide, please. So in addition to the T640 continuous PM 2.5 analyzer I mentioned earlier, we also operate intermittent samplers to measure PM. So we have different samplers for PM 2.5 and PM 10. We operate 3 PM 2.5 samplers at 2 different sites and 5 intermittent PM 10 samplers at 3 different sites in the state. Our agency operates the Thermo 2025I. Oh, I'm sorry, the light shut off in here. That happened earlier. Our agency operates the Thermo 2025I PM 2.5 sampler and the Thermo 2000I PM10 sampler. Both of these samplers operate very similarly by pulling air through a filter at a set flow rate for 24 hours. The filters are then sent off to a lab where they are gravimetrically analyzed to determine a 24-hour average concentration for that day. Next slide, please. So the next type of intermittent sampler we operate samples for lead. Lead is a naturally occurring element that is toxic if inhaled or ingested. The largest source of lead emissions today come from battery production plants. We operate 2 lead samplers at one site near one of these production facilities. Our agency utilizes the TISH lead sampler, which collects samples on a quartz fiber filter. Air samples are pulled through a sample system at a known flow rate for 24 hours. And once collected, the filters are sent off to a lab where they are analyzed by inductively coupled plasma mass spectrometry. Next slide, please. So the last type of intermittent samplers we operate are used to collect air toxic samples. Air toxics contain a wide variety of substances that can cause neurological, immunological, reproductive, respiratory disorders, or it can be human carcinogens. Samples are collected on different types of sample media depending on the specific air toxic type. We operate one TISH PAH sampler that collects samples on filters similar to the lead sampler we saw previously. These samples are analyzed for polycyclic aromatic hydrocarbons. We also operate Zontec 911A air toxic samplers at 3 different sites. They collect a known volume of air in a canister to be measured for a suite of over 50 different compounds. And then lastly, we operate one ATEC 2200 VOC and carbonyl sampler, which collects known volumes of air in a canister similar to the Zontec sampler for numerous compounds, as well as collects carbonyls on a filter cartridge for analysis. And all of these air toxic samples are sent out to a contract laboratory for analysis. Next slide, please. So in addition to all of the analyzers and samplers that directly measure air pollution levels, the Technical Services Branch also maintains over 100 pieces of equipment that support the air monitoring network. These include all of our standards we use to calibrate, certify, audit, and check all of the monitoring equipment. Things like flow meters, temperature and pressure standards, critical flow orifices, dilution gas calibrators, manometers, and gas cylinders. Each standard has a service life of 6 to 12 months before it either has to be sent back to the manufacturer for recertification or returned to our lab here in Frankfurt for recertification. Next slide, please. So in addition to collecting samples and measuring pollutants in the ambient air, the Technical Services Branch is also tasked with ensuring we are collecting quality data. This is done several different ways, the first of which is through performance audits of the monitoring equipment. The Quality Assurance Section conducts routine performance audits of every analyzer and sampler in the field each quarter. This ensures that each piece of equipment is operating within its specific limits and is collecting accurate data. Gas analyzers are tested against known concentrations of pollutants, while particulate matter and VOC samplers are checked to ensure their flow rates are accurate. The bottom left picture is one of our QA staff members conducting audits of gas samplers. And on the top right photo is another member of our staff checking the flow rate of a PM 2.5 sampler. Next slide, please. So in addition to our quarterly performance audits, our site operators perform and document checks of the equipment on a biweekly basis or monthly basis, depending on the specific instrument. The results of these checks are used to determine if a piece of equipment needs to be calibrated, maintained, or replaced. These checks are used to help ensure data quality by demonstrating accuracy of the equipment. The top left photo depicts an ozone sampler QC check, so that's the data we receive back from that analyzer while we test it, where the SO2 analyzer was fed known concentrations of gas. Then that information is then recorded on an Excel form, like in the picture on the right, that automatically calculates the accuracy of the analyzer at the time of the check. And then the bottom photo shows a biweekly flow check being performed on a PM 2.5 sampler, ensuring that the flow rate it produces is accurate and within limits. Next slide, please. So in addition to all of the performance audits and biweekly checks performed on our monitoring equipment, the Quality Assurance Section also reviews and validates every single minute of data collected by all of our continuous analyzers and every 24-hour sample collected by every single intermittent sampler in the state. This is done by reviewing monthly data reports for all of our equipment. This amounts to over 24 million individual data points for our continuous analyzers and over 900 individual samples for the intermittent samplers, all being reviewed every single year. Next slide, please. So the last way we help ensure data quality in our network is by undergoing routine audits by the EPA. Each year, the EPA conducts performance audits of 25% of our entire network as part of the National Performance Audit Program for gaseous analyzers, and then through the National PM2.5 Performance Evaluation Program for PM2.5 analyzers and samplers. The EPA also performs technical systems audits of our network every 3 years. They evaluate 3 years worth of data collection for our entire network. They look at monitoring sites and how they are set up. They look at how we review our data and how we audit our equipment and every other aspect of our work. The end result provides us with recommendations to improve our processes and monitoring network. We work with the EPA closely to constantly improve our quality system. Next slide, please. So now that we have ensured we've collected quality data, what do we do with it? The data we collect is used to demonstrate compliance with or progress toward meeting the ambient air quality standards set by the EPA. These standards, referred to as the Primary and Secondary National Ambient Air Quality Standards, or NAAQS, ensure public health and safety to the public. The data is also used to identify pollution trends in the state and inform results on special studies. Lastly, we also report our data and pollution levels for the Air Quality Index, or AQI, which I'll talk about in more detail shortly. The data we collect can be accessed several different ways. Each year, the division issues a detailed summary of the previous year's data in our annual report, which can be obtained on our website. We also report our data to the EPA-operated websites that provide access, analysis, and visualization for data like the AQI and AirNow. Next slide, please. So the Air Quality Index is a tool that was developed to make it easier to understand pollutant levels in the ambient air. The AQI uses a color-coded system to communicate this information to the general public in a simple manner. The AQI converts concentrations of data collected at air monitoring sites into a number between 0 and 500. Each color of the AQI scale is related to potential health effects in the populations that are most at risk, like small children or individuals with respiratory conditions. You can find the AQI for your area on the AirNow website, a link for which can be found on our division's website. Next slide, please. So in addition to the AQI, AirNow is a great all-in-one tool for air quality data. Not only does it house and display data for the state of Kentucky, but also for air quality data collected around the country. AirNow includes an interactive map where you can view air quality data trends on a national, individual, state, or single air monitored level. On the site, you can find resources for current air quality and forecasted air quality maps, current fire conditions, including their locations and potential smoke plumes, air quality data for Canada and Mexico, and important health information related to air quality that can be used for the public, healthcare professionals, education, and weathercasting. Next slide, please. So this is an example map of the air quality data for the state of Kentucky on the AirNow website. Each of the little circles you see represent an air monitor, or air monitoring station at least. And then each of those circles are color-coded and have a number that reflects the AQI at that area at that time. Next slide, please. So for the past few decades, Kentucky has seen a steady decline in pollutant concentrations for our criteria pollutants. The entire division works very hard to ensure the air is clean, to ensure public health, and maintain the quality of our environment. Even though concentrations are dropping, the Technical Services Branch will continue to monitor across the state and continue to improve our monitoring network with new and innovative equipment. Next slide, please. So that concludes my overview of the ambient air monitoring program in the state of Kentucky in the technical services branch. I would be happy to answer any questions you might have at this time, or if you think of anything in the future, you can send me an email at clayton.sanders@ky.gov. Okay, looks like we have one question from Allison. Can the air analyzers in Kentucky pick up the smoke coming from wildfires across the U.S.? So yes, our continuous PM 2.5 analyzers, the T640 I mentioned earlier, they are very sensitive to particulate matter, including wildfire smoke. So last year, or maybe this year, during the Canadian wildfire event, our analyzers were able to pick up that smoke plume that was coming all the way from Canada. Whenever there's a prescribed burn or a wildfire in Kentucky, our analyzers are also able to detect that several counties away. And we actually had, if you remember the Saharan dust episode a few years ago, our analyzers were actually able to pick up on that particulate matter as well. Great question. And I don't see anything else in the question thread. Like I said, if anybody ever has any questions about ambient air monitoring in the future, please feel free to shoot me an email. My email's there at the bottom of the slide. If I can't provide you with the information that you're asking for, I'd be happy to get you a hold of somebody that can help you out. Thank you all
Clayton, it
for
looks like we
tuning in.
actually have, oh, sorry.
I was going to, do we have another one?
It looks like we do. We had a question that says, do you have monitors for toxins in the west end of Louisville?
So our division itself does not operate in the county or in the city of Louisville. That is all left up to the Louisville Metro Air Pollution Control District. I do know they sample for air toxics within Jefferson County. I'm just not exactly sure where those are placed. Um, but I do know they sample for air toxics there.
Okay, we have another one. This one was actually from me. So speaking
Okay.
of, the smoke coming from wildfires, are there any other common events or activities that happen specifically in Kentucky where you see, increases in the monitors?
Occasionally, the real easy one is ozone. Like I mentioned, we don't measure for it in the winter just because its production is directly related to sunlight, which we don't have a lot of in the winter. But in the summer, is typically when those concentrations come up. So on really hot, sunny days in the middle of July and August, we typically see upward trends in ozone. Um, Outside of that, I can't think of any real specific events that like always show up on our analyzers, but I mean, we catch things like daily traffic trends. We have, our sites near roads catch, the morning commute and the afternoon commute. We see an uptick in NOx levels and things like that. So there isn't any like big impressive events that I can point to, like a wildfire, but they catch a lot of different shifts and changes that can be pretty easily correlated to things we see in everyday life.
Great, thank you. I don't see any more questions right now, but like you said, if anybody does have any questions or thinks about anything later on in the day, they're like, oh, I wish I would have asked that. I'm sure Clayton would love to get an email from you. And like he said, if he doesn't know the answer, he can point you in the direction of somebody who will be able to answer that question for you. So nothing else is popping up. Go ahead and thank you, Clayton, for joining us today and giving this awesome presentation about ambient air monitoring in Kentucky. I know I learned a lot just from it, so we really appreciate you joining us.
Yeah, of course. I was happy to do it.
So let me go ahead and share my screen really quick. Let's see if it works. Let's see, just a little bit of post-event housekeeping. We will have an event survey made available directly after the webinar. It will actually pop up on your GoToWebinar screen, just a few questions about how we're doing. And it will also ask if you have any ideas for future events for us. So we are always looking for new ideas for our webinar topics. Anything that you might think of, you have questions about, feel free to put it in there. We take a look at all of those, and they are really useful to us. And then, as I said in the beginning, the webinar recording and presentations will be made available to everyone who was registered. Just give me a day or two to pull that all together, and it will be sent to the email that you used to register for the event with. And then finally, also like I mentioned in the introduction, we do have some upcoming events that we would love to see you at. Next month, our ECAP recap topic will be featuring one of our department's basin coordinators, and he's going to be talking about what they do and how they work to protect Kentucky's water. And then we also have a Water 101 and a Waste 101 scheduled. These are going to be our introductory permitting and compliance workshops, which will be located in Moorhead, Kentucky. All of these events are listed on our website, and when we send these slides out, they are linked under this slide as well. But if you have any questions for us ever, feel free to reach out to us. This is our hotline number, so it goes straight to ECAP staff, 502-712-6189. We also have an email address, again, that goes straight to our ECAP staff, so one of us will get back to you and answer any questions that you might have. And that is going to be envhelp@ky.gov. So with that being said, we want to thank everyone for joining us this morning. A big thank you again to Clayton for joining us and giving us this awesome presentation. We hope you have a great rest of your day, and we hope to see you at one of our events in the future. Thank you all.